Hello everyone, welcome to this session on georeferencing of scanned maps in QGIS as part of the online training program on Introduction to Remote Sensing and GIS using QGIS. Till now we have seen the basics of remote sensing and GIS, introduction to QGIS and its installation, then open access datasets. Then we started working with delimited text data in QGIS, followed by vector data in QGIS. And then we have seen how we can create a basic map in QGIS. Now we are coming to the data preparation part. Creation of vector data starts with georeferenced raster layers. In this session, we will see georeferencing. In the coming session, we will see how to make use of satellite imagery and use digitization tools to create vector data. So before digitization, georeferencing is an important first step that is to be done. Suppose if you have paper maps at your office, old maps with lot of information, if you want to make use of them, you can scan and then georeference your paper maps before digitization. In this session, we will see how to georeference a PDF map using QGIS. Georeferencing is the process of assigning real-world coordinates to each pixel of a raster file. A georeferenced raster data is required for creation of vector layers in any software, GIS software using digitization tools. In case of a georeferenced aerial or satellite imagery, generally the positional information is already stored. It consists of information in the form of coordinates of the topmost pixel, top leftmost pixel, and the size of each pixel in X and Y directions, and the amount by which the image is rotated, if any. Suppose you have paper maps at your office, old maps are available with good detail, and you want to make use of them and digitize it and then create digital GIS layers from the old map. The first thing you can scan it. You can scan it as an image file at a very good resolution. Take a good scanner. At least take the resolution of at least 300 dpi. Suppose if it is a colored map, you can scan it in color so that you can later use those colors to separate information and create different layers. And if your map is very big, then you have to scan it in sections, and each section has to be georeferenced separately, and then all those raster layers. Once you scan, it becomes a raster layer, and then you georeference it, and then you have to merge them. Try to minimize these number of sections. If you can scan the whole map in one go, it would be better. At least 4 ground control points with known coordinates are needed for georeferencing. Now you can get the information about the coordinates from the ground. You can go to the location and collect the coordinates using GPS. Or if it is a very prominent location, the coordinates of such locations are they are well known. They will be available in public domain. Or in the scanned map itself, there may be a grid of coordinates which you can make use of for you can make use of intersections of those latitudes and longitudes, the grid points as known ground control points. Or if the map has, as I said, if it has any prominent locations, some monument or some junction of roadways, or some other public utility building, the coordinates of those known points can be used as ground control points. For our purpose, we will be using a Survey of India topo sheet in PDF format. We will treat it as a scanned map and use it for georeferencing. The same file is being provided to you in the exercise data. However, you can go to Survey of India online maps portal and you can download the topo sheet of your area of interest and then do the same, follow the same procedure. So you had seen yesterday how to create login credentials for Survey of India online maps, from where we downloaded the administrative boundary database and village boundary database as shape files. You can also download any of the topo sheet in as a free PDF file. Let us have a look. You can search for Survey of India online maps, and then you log in using your mobile number and password. If you are knowing the topo sheet number of your area of interest, then you can search easily using the number. Yeah, once you log in, you check this tab of products, and under digital products filters, you can check open series map free PDF section, and then click to buy. Here you will find the you can search the Survey of India topo sheets of at the scale of 1:50K, 50,000. You can enter the sheet number directly. Like for Pune region, I know the sheet number 47F by 14. Yeah, otherwise, even if you don't know, you can simply click on this sheet number. You can see this reference map. You can enlarge it and see the reference map for your area of interest. You can find the topo sheet number from here, or you can click on this search sheet number. Then you can select your state and district. Then it will list out all the topo sheets from the district. Now the number which I am looking for is 47F by 14. So I will select this, and then I will download. Yeah. So this is my topo sheet. You can check the projection. Earlier, they used to make use of local datum, but now they are using WGS 84 datum, and this is in UTM projection. The scale is 1:50,000, and you can see the grids of latitude and longitude numbered. You can make use of these intersections as ground control points, or you can even zoom in to the map for known locations like railway stations, public buildings, intersections of major arterial roads, etc., which for which you can easily get the coordinates, ground coordinates. For this training program, I am also providing you the exercise data for each day in this format. I am uploading the exercise data for this example. Say we have this topo sheet which I had downloaded as a PDF file. It will be the input data which will be available in the exercise data, and once you do the georeferencing, the final georeferenced PDF file or raster image will also be made available in the solution folder. However, it is suggested that you follow the steps and do it on your own, and then you can cross verify with the final product. You can make use of your own input topo sheet by downloading it from Survey of India online maps. Now let us launch QGIS from the startup menu. Earlier versions of QGIS, georeferencing was done in the old versions using a plugin, georeferencer plugin. We will come to the plugin architecture of QGIS. We will explain in this session itself. We will come to how to install plugins. Um, for now, we will start a new project. You can save it as, like, I will go to my solution folder and I will save it as a QGIS project. I will name it as georeferencing. So let now you will find now the georeferencing option will be under the main menu. Under layers you will find this georeferencer option. You can click it, then it will open this dialog box, and then you can load your raster file using this button. You can click it and then you can browse to your exercise data. If you are having a scanned map in the form of JPG file, you can load it, or you can even directly load the Survey of India topo sheet. So it will, this dialog has two sections. One where you will be seeing your scanned map or the PDF file, and then there will be a ground control point table which will show you all the ground control points that you select on the map on this layer. Now let us try to select the ground control points from in the georeferencer window. What you can do is you can use your mouse to scroll. We will select these four corner points of the grid of latitude and longitude as our ground control points. You have to at least choose 4 ground control points for georeferencing, but the more number of ground control points you choose, the better will be your final georeferenced layer. You can choose the ground control points spread over the whole image instead of selecting them from one portion, one particular section of the image. So let me, so here you can see what you can note down the coordinates. The x coordinate is the longitude 73 degree 45, and then the y coordinate is the latitude 18 degree 45 minutes. So zoom to the maximum possible extent. So this is the point. You can select the option of add point. You can click on add point in this georeferencer window and then click here, and it will open a new dialog of enter map coordinates, where you can give your x and y coordinates, known coordinates, like we had seen. Our coordinates are 73 degrees. You can convert it into decimal, 70 in minutes into decimal, or you can just simply press space bar and then type the minutes. Suppose if you have even seconds, very precise location, if you have GPS coordinates, you can even give in the form of degrees, then minutes, and then seconds. Right, and then now we will the y coordinate is 1845, 18 degrees 45 minutes. Here we are selecting the global coordinate system, the WGS 1984 datum. with EPSG code 4326, and then press OK. So you will find a new record has been added in the GCP table, and you will also find a new point in red, ground control point added in the georeferencer window. Now you repeat the process for selecting the other corner points. So this is my second corner point. It is taking time to load. As you can see here, even though you have given the input in the form of degree and minute, it has converted into decimals, 73.75 longitude and 18.75 latitude. Now here my coordinates are 74 and 1845. Let me zoom in to the maximum extent. Select your GCP and input your x coordinate, which is 74, and y coordinate 18 degrees space 45 minutes, and then click OK. So I have selected all the 4 ground control points at 4 corners and have given the input of x and y coordinates. You can even select the fifth GCP at the center of the image. So you can make use of these options of pan, zoom in, zoom out, and zoom to layer for selection of your ground control points. Now let me select my fifth GCP, add point, click here, and my coordinates are 73 degree 52 space, give a space 52 minutes and then 30 seconds, and my latitude is 18 degrees 37 minutes and 30 seconds. Can click on zoom to extent. So I had selected 5 ground control points, and now I have to select my transformation settings. Then I can go for georeferencing. Before going for transformation settings, you can also add ground control points from the map canvas area. For example, if you have this such intersection of major arterial roads, you can display the base map like Google Satellite Map or Google Roads Map in your map canvas area, main QGIS map canvas area, and then you can select the option of adding a ground control point by zooming in and clicking on the intersection point, and you choose this option of from map canvas area, and you go to your base map, which is a georeferenced raster layer, from where you can collect the coordinates by clicking on the same point in the same intersection of roads in the map canvas area. In that way you can add more ground control points. Anyway, here we have only selected 5 ground control points from the graded coordinates. So let us go for setting up the transformation settings by clicking this option. So here in the transformation type, there are many options that are available. Linear, polynomial 1, 2, 3, thin plate, spline, projective, etc. Now, basically, the depending upon the number of ground control points and depending upon the type and quality of the input data and how much geometric distortion uh, that you can allow in after the transformation, you can select the type of transformation. For example, the linear transformation, it only allows translation with uniform scaling without any rotation or transformation. It is used when you have a very good quality raster map of known coordinate reference system. Then you can go for it. You can go for polynomial functions transformations which allow for curvature. If you have photograph for the maps, you can go for thin plate spline. If you don't have a very good quality, you have a deformed paper map, this is also known as this. What it does is it rubber sheets the raster using multiple local polynomial transformation. You for this plate spline, you at least need 10 ground control points, and it will try to match the ground control points, and it will does the multiple local polynomial transformation. It is useful, as I said, for damaged or deformed maps and where the projection is not known. Now here in our case, we will just select this thin plate spline option. However, we have only selected 5 ground control points. Anyway, this is for demonstration purpose. And the target CRS, you can select the global coordinate system, that is EPSG 4326 WGS 1984. WGS 1984 is the datum. Um, as you are giving the input which is a universally accepted datum, you are also giving the input of the coordinates as latitude and longitudes, which are the global coordinates. Then you can select the file, the georeferenced file. It automatically gives the name of the your original file and underscore modified, and it saves as a TIF, the geotiff raster layer, in the same exercise folder. You can modify it if required. I will save it in my solution folder with the same name. And then the resampling method, here also you have many options, but generally if you don't want to change the statistics of your raster, you can go for nearest neighbor. You can select cubic spline for smoother result. Now let me keep the default option as it is. You can check this option of save ground control points and load in project when done. Then once after georeferencing is done, the georeferenced raster will be loaded. Then click OK for finalizing the transformation settings. And now for doing the georeferencing, you can go to this option of start georeferencing. So you can see the progress here. It is georeferencing the layer using those 5 ground control points and the given transformation settings. Now, if you are careful enough to select your ground control points, it will show you a very low residual pixel mean error. So you should keep it as minimum as possible. Uh, if you are going for more ground control points, it will come down. So now the georeferenced raster is loaded in the main map canvas area. Uh, you can close this georeferencer window, and now uh, you can check your georeferenced layer by zooming the layer. You can take your mouse onto the map canvas area, and you can check the coordinates here, which are getting displayed. This is in these are the global coordinates, latitude and longitude. You can verify it, like this this was our original GCP. You can check for this point. The latitude is 18.70. That is actually it is in minutes and degrees. 18 degree 42 minutes and 30 seconds, whereas the longitude is 73.75, which is 73 degrees 45 minutes. Anyway, there is another, we will let us try to add a base map using plugins, quick map services plugin, and check our georeferenced layer. As stated in the inaugural session, QGIS as a plugin architecture, plugins are actually it enable the users and developers to extend the core functionalities of QGIS by writing programs for specific purposes. They are just like mobile apps. You can check for QGIS plugin official repository, QGIS plugin repository, and go to this URL plugins.qgis.org, which has all the plugins which are available in this repository. There are about 1000 to 2000 plugins which are there in the repository. You can check for any of the plugin, what it does, who is the author, and what is the latest plugin version when it was created, and the rating given by the users. So more popular plugins you will find under popular tab. The first one, as you can see, is Quick Map Services, which we will install it now for adding the base maps. You can check for other plugins. We will be also be seeing this semi-automatic classification plugin and Quick OSM plugin. These are the very popular plugins. Profile tool plugin also we will see. This semi-automatic classification plugin, we will use it for land use, land cover classification. Quick OSM for fetching the OpenStreetMap data directly without the need for downloading. We had seen in the previous in the third session on open access data sets how to download OSM data, but we can do it using the plugin itself. Then quick map services, we will look at it now. Now if you in the main menu of the QGIS, in the main menu, if you go to this section of plugins, it is from here you manage all the plugins. For installing any plugin, you need to be connected to the internet. You can click on manage and install plugins. Then this dialog box will open. It will list out all the plugins which are available under all tab. There are about 1194 plugins. If you click on installed tab, there are some plugins which have already been installed, like for example processing. This is a core plugin, processing, and you cannot uninstall it. It provides the spatial data processing framework for QGIS. In the main menu, from the processing menu, if you click on toolbox, you will see all these tools which are available. Many of the tools and algorithms which are available section wise, they are there: vector analysis, raster analysis, so on. These are the many tools which is provided by this processing framework. This is the core of QGIS. There are other core plugins which are installed, like when we installed QGIS, you have seen that it came along with GRASS and Saga GIS. So this Saga GIS provider and GRASS GIS provider, these are also the core plugins which they are already installed, and you cannot uninstall them. Now let us go to all tab and search for quick map services. So this quick map services is an easy to add base maps and geo services. You will see the description here, the website. The developer is Next.js. Now these plugins are created either by individuals or organizations for specified purposes, like this one. Now to install the plugin, you can just click on this install plugin option. It will hardly take a few seconds, and then you close. Now in the main menu, you will see a new tab of web has been created when you install the Quick Map Services plugin. You go to this web and you will find Quick Map Services option here, and then you will find two options. There are four base maps which have been added: NASA, CDAC, earthquake hazard base map, and then OSM, the OpenStreetMap standard. You can click on this OSM standard, which will add a base map of OSM standard. The layer, as you can see, the layer of OSM standard has been added. You can keep your georeferenced layer on the top of this OSM standard. You can change the transparency levels of this georeferenced layer by right clicking and going to properties, and then checking the transparency. You can change the transparency levels to about 50% so that you can see the base map, and then you apply it. Now you can see the base map. You can check and uncheck the layer of the georeferenced layer and see how it tallies with the base map. The river, especially the main arterial junctions, rivers, etc., it is almost tallying exactly. Your georeferenced layer is tallying exactly. So your georeferencing has been come out to be, it has been fairly good with minimal error. You can even check the error when in the georeferencer window. You must have seen the residual error. You should always try to aim for minimizing that error by selecting your GCPs, the ground control points, and maintaining and giving the coordinates. If you select more ground control points, and if you are giving the correct coordinates from either from the map canvas or from the gridded coordinates, it will the automatically the error will come down. So anyway, let us now you have added a base map of OSM standard. Now if you want more options of base maps, if you want to say, if you want to add the Google satellite image and check your georeferenced layer, so that can be done. So you go to this is one time you have to set the settings of Quick Map Services. You go to web and Quick Map Services option, and then click on settings. If you click on settings, you go to this more services. In the Quick Map Services settings dialog box, you go to the tab of more services, and then click on this get contributed pack. So it will show you that last version of the contributed pack was downloaded. Then you can save it, save the settings. And now if you check under map, under Quick Map Services, you will be finding multiple base map. The options, you can find them. You can check for Google, and then click on Google satellite. So you have the Google satellite base map has been added. You can now uncheck this OSM standard layer, and let me also uncheck the georeferenced layer. So this is the Google satellite base map. You can zoom into the you can zoom on the reference georeferencer layer. You can right click and click on zoom to layer to see the full extent of the georeferenced layer. You have already set the transparency levels to 50%. Now let us look for some specific locations, because this is a high resolution imagery which is available. You can zoom into the extent possible, and this is also from recent time. So this is the airport of Pune. You can check the airport of Pune. Now this is the original topo sheet is from a um old date. Therefore, what you can check is you can check for the natural features as well as major arterial intersections. You can check. For example, this confluence point of Mota and Mola rivers on your georeferenced layer. You can check the base map satellite layer. You can see this is the confluence point as it is. So it has the georeferencing is more or less has come out to be accurate. Then let us check for some other points like this intersection of these arterial roads. You can also check, and you can check any other historical point like this Shaniwar Wada. This one. Yeah, you can see this rectangular feature which is Shaniwar Wada Fort. You can check for other natural uh, features. There is a pond or lake here. As on date, it may not be having the same extent, but still you can check. So yeah, you can see the bund that is almost coinciding, but the extent has come down. So in this way you can add your base maps, and you can visualize your layers, not just this georeferenced layer. You can add any of the layer. If you have a road network layer, you can just add the roads layer, vector polyline layer, and you can check with the whether it is overlaying on the uh, base map. Now this base map is if you check these Google satellite and OSM standards, they are in a different CRS, coordinate reference system, which is EPSG 3857 transverse marketer, which is generally used for depicting the maps. In Atlas also they are in the same projection system. But QGIS, there is not much difference between because this EPSG 3857 is also using the same datum WGS 1984, but it is a projected coordinate system, whereas EPSG 4326 is a global coordinate system which is unprojected. It has the coordinates in the form of latitude and longitude. Even in EPSG 3857, the coordinates are in latitude and longitude, but it is a different coordinate system. If you suppose if you go for UTM projection, it will have a different code, EPSG code, and there the coordinates will be in the form of easting and northing instead of global coordinates of latitude and longitude. So whatever layer you add in a different CRS, because of QGIS has this functionality of on the fly projection, all the layers will be overlaid on top of each other For visualization purpose, QGIS automatically does the reprojection, and it will reproject. It will not change the projection CRS of the individual layers, but for visualization purpose, on the fly, the projection, all the layers will be overlaid to match the project coordinate system. For example, the project coordinate system here is EPSG 4326. You can change it by selecting the any projected coordinate system from here. So we will see this CRS, how to change the project CRS, etc. afterwards. So in this session, we have seen how to georeference a scanned map or a survey of India topo sheet.